Hello everyone. Today we will continue to finalize the material of topic 2, the instructions. So we will cover two sections, 2.8 supporting procedures in computer hardware. Although we already covered that in class actually, but because we covered that in a kind of a rush way, so here I want to emphasize a few points. And then we will talk about 2.10, the MIPS addressing for 32-bit immediates and addresses. This one will talk about the main focus is to talk about the jump because the branch that's kind of immediate one we already talked. So the jump is kind of a type of the format we haven't talked how to deal with the addressing. And again, the section 2.8, section 2.10 are the index of the sections in your textbook. You are required to read corresponding material in order to get better understanding. And in last class, we talk about leaf procedure, right? And we also talk about non-leaf procedures, or we call it nested procedure. What's the difference between these two procedures? Please just pause here and try to answer by yourself. The difference between the leaf and non-leaf procedures are the leaf procedure will not include any procedure call. In other words, those procedures itself will play as the callee, potentially will be called by the caller. So for the non-leaf procedure, they will have procedure call. In other words, they will play as a caller and they will call the other callee. Because of the role are different played by the leaf procedure and non-leaf procedure, we will treat the situation whether you need to push some original data of the register into the stack in different way. If it's a leaf procedure, well, as long as that register preserve the register, and the preserved register will be touched by this leaf procedure, we will push that into the stack. If it's a non-leaf procedure, I don't care whether these registers are preserved or not, as long as that register potentially will be touched during the procedure call. In other words, can be touched by the callee, we will push that an original value of the register into the stack. Okay, so we can see here, this example we already talked in last class. So here, just to mention again, this one talk about the factorial, right? And factorial is what? It's basically try to calculate the mathematically the factorial of n. So which is equal to n times n minus 1's factorial, right? So, and then it's still equal to n times n minus 1, and then times n minus 1's factorial, minus 2 factorial, because n minus 1 factorial is equal to n minus 1 times n minus 2 factorial, and then so on, right? Because of that, we have the idea or the C code to implement this factorial implementation as following, right? If if n less than 1, what it means is if it's 0, right? If it's 0, 0 factorial is equal to 1. So that means if n minus 1, if n less than 1, we will return value of 1. Otherwise, we will continue to calculate, right? N factorial equal to n times n minus 1's factorial. And I also know the argument is in the register A0 and the result return value is in base 0. So now the question is how we can represent assembly language correspond to this code. Again, we said the as long as this is the decimal is include procedure call, right? Basically call itself. So that means this one is a nested procedure, or we call the non-leaf procedure. Therefore, as long as a certain register will be touched during the procedure call, I need to make sure to push that data into the stack, right? So here, definitely one register will be touched by procedure call is A0, right? Because originally A0 is n. Now in the procedure call, A0 become into n minus 1. Another one actually is not explicitly detached, but actually detached, which is the return value register RA. Okay, so that means in this example, A0 and the return value RA will be touched by this procedure call, because originally the return value and this register correspond to the here, right? So basically, original return value is correspond to the whole procedure. But later, after do the procedure call, if you recall, procedure call achieved by jump and link. Basically, the RA will be replaced by PC plus 4, and the PC is correspond to the instruction during the procedure call. Okay, so I think we talked about that in class last Saturday. Last Wednesday, but I just want to mention again. Again, in this example, A0 and RA be touched. So now let's look at here. This is the assembly language. I think we went through already, but here just went through again. Let's go through again. Just make sure I understand. Because there are two registers will be touched, I need to push the original value of these two registers into the stack. Therefore, you can see these three lines, right? So basically, I need to adjust the value of a stack pointer in order to make sure I will have two empty word space in the stack to store original value of RA and A0. Therefore, I need to adjust the stack pointer by -8, because one word take 4 spots, two word take 8 spots. After that, I will push RA, the original value of return address register, and the original value of A0 into the stack. Okay, and then after that, I will begin to decide whether this n is less than 1 or not. If it's less than 1, I do not do anything, just return 1, right? Therefore, you can see I will compare whether A0 is less than 1 or not, because 1 is a constant, therefore I'm using set on less than immediate. Okay, if it is not 1, if A0 is not less than 1, in other words, if A0 is not 0, then I will do the branch to the procedure with the label L1. That is what here is, right? You can see if A less than 1, T0 will be 1. And here say if T0 is equal to 0, means A is not less than 1, then I will branch here. But if A0 is less than 1, what that mean? That means T0 will be 1. That means this branch condition does not satisfy. I will continue with the subsequent instruction, which is add immediate. So here what they say is I will set the value of V0 as 1, right? Because we said is n 0 factorial is equal to 1, right? So after that, I will adjust the stack pointer and then do the return, jump and the return. So just to say one more time. So basically what here means, this main body means I will compare whether A0 less than 1. If A0 less than 1, that means this branch of equals condition not satisfied. I will continue with the next instruction to set the return value register V0 as 1, and then adjust the stack pointer back to the original value, and then implement return address. Okay, so here actually you will find one thing is interesting. Interesting thing is I does not do the pop off. You can say I push into the stack by using to store word, but I didn't pop off these two original value by using load word. I think we discussed in last class. The reason is because during this main body implementation, no one really changed the value of RA and A0. Therefore, it's okay if you want to still using load word, do the pop off, but it's not necessary because original value of RA and A0 does not change. Okay, so now let's see if this condition satisfied, branch condition satisfied. In other words, if A0 is larger or equal to 1, then we will branch into the procedure with the label L1, right? What here we'll do is I will adjust A0 from n to n minus 1 because you need to prepare your argument register before you do this procedure call, okay? So now this one means A0 is equal to n minus 1, and then we'll call this the overall procedure factorial, basically call itself. After the call, you can see the return value will be equal to the V0 now is equal to factorial n minus 1, right? And then what I do is I need to calculate n times factorial n minus 1. Where you find the n? N is the original value of A0, right? Therefore, you can see here I pop off the original value of A0 from the stack using load word, right? And then I will, here you do not have to pop off the return address register here, but you can just pop out right before the jump and the return. In other words, you can pop off this original value of RA right before you use this RA again. But here, as I said, the high-level language and assembly language is not one-to-one mapping, so you still can just pop out together. So basically, I pop off A0, original value, I pop off the original value RA. Right now, A0 has the value n, so I can using the value in A0 times the value in V0, right? A0, V0, okay? That's why you can see here, I will do the multiplication between A0 and V0 using that value to update V0. Another thing to forget, after you pop off the value, you need to release the original occupied location in stack pointer to be free. In order to do that, similar to here, you need to adjust the stack pointer back to the original value. Basically, you need to add that A8 back to the stack pointer, and then you will do the jump and the return. Okay, I hope it is clear to you. So another thing here, let me